Okay, so let's say you have a charged particle Q here and another charged particle Q here, and let's say I have a small negatively charged particle over here. Suppose if I displace this little bit with the distance of small distance x, right? So it will be minus Q displaced over here. I'm going to call this distance as x. I'm going to call this distance as L. So what you can imagine is this and this it will attract. This and this it will attract. So the resultant will be this way. So that means it's going to do a simple harmonic motion. So why minus? Only if you have minus and plus will attract this way. If you had plus here, plus and plus, it will repel and it will go away from here. That is a separate question which you will see separately in a different video. But for now we can do some derivations to find the omega and time period for this simple harmonic motion. So I would call this as SHM in equatorial line. So I can say f sine theta is going to act this way, f cos theta is going to act this way, right? So f cos theta is going to cancel out on both sides. So f sine theta will get added up. Okay. So f sine theta will be here. I don't have space, so I'm going to write here. So that means the restoring force two times f sine theta, because there will be f sine theta on this side and f sine theta on this side. So both should be added. Restoring force means mass into acceleration, and we put a minus here because theta, when it is positive, displacement or the displacement is positive, the force which is bringing it back, it will be negative, right? It will be acting in the opposite direction. So we put a minus here. F is K Q Q by R squared. R squared is this distance. So this is L, this is L, this is X, this is root of X squared plus L squared. So sine theta will be opposite by hypotenuse, so x divided by root of x squared plus L squared. Minus 2kq q x, I will write it separately. And this square root and square will go away, so this will become x squared plus L squared power 1 plus 1 by 2, it will be 3 by 2. So m will be brought over here, or maybe I can show it in the next step. And usually we will take x is very small compared to L, so that means x squared can be ignored. So L 2 cancels, L cube. So I'll be getting minus 2kq by m l cube. That's all. So comparing it with your simple harmonic motion characteristic equation, A is equal to minus omega square x. So that means in place of omega squared you have this. So omega squared, omega is equal to root of 2kq by ml cube. Again, if you want, you can put 1 by 4 pi epsilon naught. So 4 and 2 will cancel. Okay, so it's left to you. So the main purpose is to show you that how you can apply the simple harmonic motion concepts into this scenarios, like when you have this charged particles. So the simple mathematics, I think I will leave it to you. Okay, that's it. So that means one thing you have to keep in mind is only when you have minus, it will get attracted back and it will be doing the simple harmonic motion. There will be an attraction in this way. If you keep a positive charge here, the positive and positive will repel, which means it will go away. So that I will create a separate video. They will ask you, what is the maximum force, the location where you will get the maximum force. So that we will do it separately. Okay. So here you have to remember that only if you have a opposite charge, it will do simple harmonic motion in the equatorial line. In the axial line, it has to be the same charge, same sign of charge. Only then it will do the simple harmonic motion this way. Okay, so that I have given a separate video. Thanks.